Welcome to section 6.3 of college algebra. This is Mrs. Shiwi. We're going to look at polynomial equations a little further here, and today we're going to find the solutions of them. So our objective today is to solve polynomial equations using factoring by grouping, and the root method. We're going to find factors, zeros, x-intercepts, and solutions, which, as you've heard me say before, are pretty much the same thing. We just sometimes write our answer a little bit different. We're going to estimate solutions using our technology, and we're going to solve polynomial equations using the intersection method and the x-intercept method, and that will be with the technology. First of all, when we talk about solving polynomial equations, we are looking at the format where x minus a, like usually it's in parentheses, but not always. If you have x minus a value, that is a factor of the polynomial f of x. Then the value a is called a zero. It is also a real solution if it's a real number. And a is also called the x-intercept. So what I like to say most times is that the zero and the solution and the x-intercept all are really the same thing. It just depends on how you're looking at the problem. And we can find these very easily from the factors if we still have that x minus in the problem. And the graph will cross the x-axis at the point a0. So at that point, that's the x-intercept. So we usually write that one as a point. All right, for our first example, we have this polynomial, x minus 1 times x plus 2 times x plus 5. It's already factored for us, so this is factored form. We're going to find the zeros. Well, if it's already in factored form, you've done this before with quadratics, the zeros will be x equals, well, if we set this one, well, what's the value of a here? X minus what? It's 1. And the second one, x equals the a value here, because the formula they just showed us on the other page was x minus a. Because this is a plus, it is -2, minus -2, and x would be -5. So those are my 3 zeros. Now, how do we write the solutions? Pretty much the same way. The solutions are x equals 1, x equals -2, and x equals -5. Or you can just say 1, -2, and -5, because those are the solutions. And then for C, the x-intercepts are 1, -2, and -5. X-intercepts also can be written as a comma 0. So 1, 0, -2, 0, and -5, 0, because those are the 3 points on the graph that are the x-intercepts. All right, here's another application-based example. A box is to be formed by cutting a square of x inches per side from each corner of a square piece of cardboard. So we're starting with a square that is 24 by 24, and we're going to cut off little corners that are little squares off of each of the 4 corners and fold up our box. I'll show you a picture in a minute so you understand that. This will give a box whose height is x inches, with the length of each side of the bottom 2x less than the original length of the cardboard, using length equals, or volume equals length times width times height. The volume of the box is here. So basically they did this for you. I'm going to show you on the next page. I have a picture. So we have this 24 by 24 square, and we're going to cut off little boxes. I don't know if they're little or they could be bigger boxes, and then when we fold it up, we would get a taller box. But they are length x, so that's unknown, but they're squares. So we started with a 24-inch width here, and we're cutting off an x on this side and an x on this side. So that's why our width here is 24 minus 2x. And because it's a square, our length is also 24 by 2x. And when we fold it up into a box, we would get this shape with a height of x. So our volume formula is length times width times height, and the height is x. So let's look at the questions that we're going to answer for this problem. Use factors of v to find the values of x that give a volume of 0. So we want to factor it. It's actually already factored for it, but we're going to use those factors to find the volume, the answers. So here's the zero product property. If we know the answer is 0 and we have things that are multiplying to be it, then either 24 minus 2x needs to equal 0, 24 minus 2x needs to equal 0, that's the same thing, or x needs to equal 0. So from this one right here. So you can notice if I plug in a 0 here and I multiply it by anything, I'm going to get 0. So one of my answers is 0. If I cut off 0 on the edges, well, I'm not actually going to have a box, but I will have a volume of 0. What else would give me a volume of 0 would be the solution to this problem. So let's solve this with a little bit of algebra. Subtract 24 from both sides, and then divide by -2. And we get 12. So the other thing that would happen to my box, if I cut off 12 off of each side, then I just cut my cardboard in half and I don't have anything left to fold up into a box. So my dimensions of my x that I cut off has to be between 0 and 12, or I'm going to have a problem. The next thing we're going to do is graph the function on our calculator. So don't try to graph this one by hand because there are quite a few points. You can put it in your calculator. We are talking about volume here, so the y-axis, you're going to have to go really large. So if you put this in your calculator, you're going to want to go to like 0 to 1200 or -400 to 1200. And in the y-axis, sorry, the x-axis, they have from -5 to 20 on this graph. So if you put that in your calculator, you can put it in just like this. There's no reason to multiply that thing out. That's all they asked for was a graph. Part C, the question is, use input values. Oh, what input values make sense? Well, we kind of actually already answered that. If you think about problem A, x could only be between 0 and 12, or we didn't have a box anymore. So, and they can't actually be 0 or be 12, or we don't have a box. So they have to be strictly in between those two values. And then we're going to just graph the part that makes sense. And then part E, we're going to maximize the volume. So let's look at the dimensions that make sense are from 0 to 12 without equal signs here. I can't have it be 0 because then I have a problem, and I can't have it be 12 because then I cut it in half. But it can be right up to that. Now, if I just graph this from 0 to 12, so if you change your window from 0 to 12 and 0 to 1200, you get this graph here. Kind of fun. And then from part E, we want to maximize the volume. This is the graph of volume, so I want to find this maximum value right here. So in order to do that, I would use your calculator and push second trace or second calculate the maximum and go to the left and go to the right and hit enter a couple times, and you will get this for 1024. So the 0.41024 is the maximum of that graph. What does that tell me? This is my x. This is how much I should cut off of each corner. I should cut off 4 inches off of each corner. And then when I fold it up, this will be my volume. Okay, that's what they're asking for.